are absolutely gorgeous. Fantastically gorgeous. Now, why are they all different? Or,
Because of random numbers.
we generated random numbers using our birthdays, and assuming our birthdays are randomly distributed, which I think they are. We did a pretty good job of that, looking at that on day number 1. We're going to get different values. How are they the same? How are they similar?
Because the snowfall was still the same.
Well, exactly. We called all of our data from that same 100 years worth of data set, but you guys were pulling roughly 20% of that. Are they showing a commonality up there? Are they showing an on average commonality? Yeah. I mean, honestly, if we took all of your data and rammed it all together, chances are we'd have pretty close to the actual 100 data points that's in that population that I gave you. So that's what's cool about random sampling. If you sample randomly from a population, yeah, there's going to be differences. There's going to be differences. And some differences might be more exaggerated than others, but on average, look at where your median is, for example. Follow the median. Yeah?
Yeah.
There's a little goofy off to the left here and here, but you see, you've got a median of right about here-ish. So you've got pretty much, even though they're all different, you've got this trending of it towards the center, if you will. Now, the real differences happen in the extremes. That's what's kind of fun, and that's why I asked you guys to rerun your box plots with the modified box plot. And I don't want to get into this too much today, more than conversationally. We'll attack it more on Wednesday. A modified box plot, which is choice 6 on your stat plots, it's that last number 19. It walks you through how to get a modified box plot at the very bottom. Excuse me, it's not choice 6, it's choice 4. Sorry, I'm upside down. If you looked at number 19 and you go back to your same plot menu that you went to for your box plot, but pick the plot to the left of the box plot, it's the same thing. It shows you all the same stuff as a normal box plot, but if there are outliers, it identifies them with a special symbol. Does that make sense? So let me see if I can guess which one of your guys' data sets had outliers. Okay, you guys did. You guys had at least one. Yes, you guys? Good. Okay, you guys did not. You guys did not. You guys did. Purple right here, they did. They did, yes? You guys did not. You guys, I think, did. Did you guys, and you had a weird, is this you guys?
We didn't.
You guys did not?
We did, but we didn't.
You did, but you didn't.
Thought we did.
Cryptic. You're for the government, don't you? Well, you had a low data point, but it wasn't an outlier. We'll come back to that. You guys did not. You guys did not. You guys did. You had a high date. Your 90 was an outlier at least, right? Good. You guys didn't. You guys, ooh, that's close. I think that's a yes. That 90 is an outlier for you guys. Yeah. Did not. Definitely did. Clearly did. And did not. How did I do, except for you guys? Okay, good. How was I getting that? How was I able to tell which one of you guys had modified? Now here's one thing I can't do. I can identify most likely where the outlier is. It's probably the biggest data point, but I have no idea of knowing what the next one down would be. Because when you guys had outliers, when you redrew your box plot, there was still a box plot there, but then there was a little point on the outside. So the maximum value then became like a sixth of the, it was like a 6-number summary, right? You had min, Q1, median, Q3, max, and then so, you know, I can't identify where the new max is. John, go.
Well, I was just going to say that you, by the variance in the quartiles, you can tell if there's an outlier. So if everything seems pretty even, spread out, then you're going to know, okay, there wasn't an outlier there. But as soon as one quartile gets huge.
So, I love this, John. Thank you. Thank you. That's a brilliant. So check this out. Which one? You guys had one, right? Okay. If this had happened, would I have an outlier? If that had happened, would that change the outlier at all? Would that change the outlier? That's what you're getting at, right? The variance within the quartile?
You obviously have one off the end of it, even if you...
It has, believe it or not, John, I love what you're saying. It has nothing, are you talking about the individual 25s or the entire 50?
Well, the whole thing as a whole,
yes.
by quartiles.
That by, let's call them something different. Let's call it half tiles.
Okay.
By looking at the entire box, and the entire box is the middle 50% of data, right? The entire box in the middle. That's what I was actually doing. One of the rules for identifying outliers, and there are like 5 of them. I'm not going to do all 5 in class with you because some of them don't get used very often. But one of the more popular ones says, take this right here, which is called the interquartile range, the IQR, multiply it by 50%. So let's just look at this one right here. Take that, multiply it by 50%. Is that about right? Did I do that about right? About like that, yeah?
Yep.
Take that distance and stack it onto the quartiles like this. If anything is outside, that's an outlier. So you see, that's how I could tell that 90 was an outlier, but I could tell that that 1 was not. You see what I'm getting at? So really quickly, what I was trying to do in my head was, look at your box, make it 50% bigger, and then visually drop this on. That's how I could tell that one was. This is why your guys threw me for a loop, because it was too close. Here's your IQR, right? Increase it by 50%, stack it. It was damn close. It's almost actually, I've never had a low outlier in this class. I was very excited actually to have one, but it didn't work out this way. But this is a lot more range than I'm used to seeing down there. Because the years with low snowfalls are very, and this makes sense, I think it makes sense to us logically. The years with low snowfall, they tend to be like a foot or less. But the years with the dumps, look at the graph. The years with the dumps are huge spikes. They're well above, if you will, norms. Yeah, they're well above norm. So that's one way of identifying outliers. We'll come back to that on Wednesday. That was very, very quick and dirty. But hey, here's a question. What does this tell us about those winters where we go, oh my God, I remember those winters when there was snow on the ground for like 3 straight weeks or something. It's up to our car. They could get a tunnel out of our houses for like 3 straight weeks. Now, if you live at Crater Lake Lodge, I agree with that. Because Crater Lake Lodge, very often in Rainier, if you stay up at Mount Rainier in the wintertime, they're tunneling into those hotels into July sometimes. But how about Bend? What does this tell us about that claim in Bend? It's a bit of a trick question, actually. It's a bit of a trick question. What does this tell us about snowfall in Bend? Go, Luanda.
It's getting warmer here.
Maybe. Does the data show that? Now, for Luanda's claim, I love your claim, by the way. I love your claim. I say ignore this. Because when she says it's getting warmer, she's tying the snowfall to what? Temperature over time. I say to address Luanda's claim, go back to the data sheet and look at the pattern in the snowfall. No, I like what you're saying, Luanda. It's actually it's a worldwide claim, isn't it? Things are getting warmer. The problem with that is it's hard to see anything in this. I'm not saying it's not there. I'm saying if it's there, I'm missing it. I showed this to my buddy Franz, and he's like, oh, dude, it's clearly there. And he went like this. I was like, define clear. I see noise all over that. But he was convinced that there's a large cycle. He saw this cluster here, and this cluster in the middle. And I'm like, dude, you're calling that a cluster. I'm saying you're out of your mind. But that's okay. That's how he interpreted it. That's one way of looking at it statistically. There's a model there. Go, Patrick.
And it almost looks like in the middle, every 20 years, there's a big, and then it goes back down.
And maybe we haven't seen enough data to see that pattern yet. What Patrick is saying is you got 20, then a spike, 20, then a spike, 20, then a spike. And maybe we need a few hundred more years of data to collect before we can see anything. And maybe it will change. Who knows? I love that. Luanda, I'm not disagreeing with you.
It looks like we're just in a lull, and we're also in a solar cycle right now, and have been for the last 12 months.
Maybe that affects the weather. Affects the weather somehow.
It does. It totally does.
There you go. So I'm not, Luanda. Like I said, I'm not trying to throw your claim out. I just can't support it directly with this particular data.
We are during this period. We have been in a solar cycle.
I'm not doubting that, Tim. I trust you. I've never heard that before. I trust you. I totally trust you.
Drossman, astronomy.
Well, I learned in geology that because of all the volcanoes, it's caused the ash that has fallen has caused it to be warmer in this area. Plus, the Cascades blocks the breeze and stuff. So.
We need to get
over what time period? Is Mount are we talking like Mount St. Helens in 1980? Let's look at 80.
Yeah, I don't know. I think.
Look at the years directly after 80. Well, Luanda, if you look at Mount St. Helens erupted in 1980. Close enough to here to actually affect the weather, I would imagine. I mean, I was in Delaware when that happened, and I remember the ash falling in Delaware, 3,000 miles away, ash from Mount St. Helens landed. So you can imagine how much ash. Was anybody here in 80?
Yeah.
Do you remember Mount St. Helens exploding and how much ash we've been around? Was it a lot? I'm assuming it was tons, right?
Depends on where you were at.
Well, of course, but I'm looking at the data. I'm interested by that, because if you look after 80, the snowfall begins to fall off a little. There's a spike in 93, 96 maybe. But those could just be very, very extreme weather patterns that would have punched through anyway. I'm not saying that's not without merit. I'm saying let's go look at it a different way, maybe. Here's the one data point I do have, though. And I'll leave you with this. That is the average daily snow depth in Bend. It's a little hard to see because of the green line. They use green for some reason. This is the same website that I pulled most of that snowfall data from. It was only updated until 2005. I've been collecting it ever since then because whoever was collecting for this site decided to stop collecting. So I've been collecting ever since. All the data from 2005, 2012 is my data. So this is average annual snow depth on the ground from January 1st to December 31st. Isn't this interesting? There is a spike around February 1st, it looks like. So the month of January is a good snow in the town of Bend. This is in the town of Bend. This isn't Bashment, obviously. They went out of business. So this is the town of Bend. But look at the average annual snow depth. 2 inches on average. So I am not claiming that we do not remember snow that's up to here. I'm claiming that we have forgotten all the years where the snow was down here. And we, for some reason, remember that crazy snow year or two when the snow was packed up for weeks and weeks and weeks. Not saying it didn't happen. I'm guessing it happened in 1973. I'm guessing it also happened in 1993. I'm guessing maybe it happened in 1994. But I'm saying in the year where it snowed 10 inches in 1982, I doubt very much there was 2 inches of snow on the ground for the entire month of January. You see what I'm getting at, friends? Yeah. On average. And the problem is our memory is pretty subjective.
Right.
We tend to remember the extremes.
It's romanticized too.
And romanticized as well, of course. But there might be some truth to that. Luanda and Tim are saying, I'm not saying there's not truth to that, but we're in a warming cycle. I'm not saying that. I'm saying this data doesn't suggest that. We want to see more data and more data points. So, I'm not taking a side. I'm just saying. We can't read too much into this very, very simple set of 100 data points that I've collected for you. Okay, for next time, 3 things. Number 1, might be 4, potentially 4. Number 1, do the exam corrections for sure, for your in-class exam part. Get that knocked out. Number 2, bring questions on relative position. That's the next homework assignment. I've made some videos for that in front of that. I'm trying to stay in front of you guys now for the homework assignment. So you've got videos out in front of relative position. I have at least 1 quiz on the website now. I might throw a second one up there. Again, they're all optional, so you don't have to do either of them if you don't want to. But I'm going to try to get a second quiz up. I thought of a fun little quiz idea that maybe have you guys do. If I can get it done between now and Wednesday, I'll do that. But they definitely have the 1 quiz up there. So an optional quiz, totally do exam corrections, and bring questions on relative position for Wednesday. Wednesday is the median of our class, is it not? Holy crap. After Wednesday, we're half over.
Are we turning this in?
Depressing as hell. Yeah, well, please, I'll just get 10 points. Did you guys 2 points each just for the 5-number summary? That's all you had to do to get the points, yeah? So please, make a pile right here. This will be the easiest thing Amber ever grades. Yes. And make sure your names are on it, yeah? All right. Have a good day. Drive safe. Stay warm. Stay healthy. Hydrate. Hydrate.
Is this still recording?
I got some good.